Think about the last text message you sent to someone you've never met face to face, a customer service rep, a forum user, a random account. How do you know for a fact that there was a living, breathing person on the other end? If your life depended on proving the entity typing back to you had a pulse, how would you actually do it? In 1950, a mathematician named Alan Turing proposed a way to measure exactly that. He called it the imitation game. The premise is straightforward. You have a human judge communicating via text with two hidden subjects. One is a machine, one is a person. The machine's entire objective is to fool the judge into believing it is the biological human. For over 7 decades, no computer came close to pulling this off. The processing limits and physical architecture of early machines meant their text responses were rigid, robotic, and instantly recognizable. Because of that decades-long failure rate, we developed a habit of blind trust. When we open a help chat or read a comment thread today, we assume we are interacting with our own species, because computers have historically lacked the nuance to fake it. We grew comfortable treating that 74-year streak as a permanent rule of technology. But last year, that comfort quietly evaporated. In 2024, researchers at UC San Diego, led by Cameron Jones, ran Turing's original 1950 experiment. They used the exact parameters he laid out, executing a strict, peer-reviewed study. They took modern artificial intelligence running on a GPT-4 architecture and pitted it against a large pool of human evaluators in a highly controlled environment. The data from those trials showed the AI matched the human baseline. The evaluators could not accurately separate the machine from the real people. These were focused participants sitting in a lab, actively hunting for the slightest hint of artificiality, and they still guessed wrong. These results suggest that a person passively scrolling their phone, distracted by daily life, lacks the scrutiny required to reliably catch the deception. The researchers moved past the simple pass-fail results to analyze the specific scores given to each participant. The detailed breakdown of the test scores revealed a secondary pattern in the data, one that contradicts how we expect these systems to behave. This is a chart showing the convincing as human success rates from the 2024 study. The GPT-4 system achieved a higher success rate at convincing the judges of its humanity than a measurable percentage of the actual living, breathing humans in the control group. The human participants often failed to prove they were real because our natural communication is messy. We make odd typos, we get defensive, our tone fluctuates, and our grammar is frequently erratic and unpredictable. The AI, by contrast, analyzed our collective communication habits and delivered exactly what a judge expects a normal person to sound like. The system fed the judges an idealized version of human dialogue. It bypassed how real people actually type and instead simulated the precise psychological profile of a cooperative human subject. The machine optimized our own language against us. It performed humanity so efficiently that inside the vacuum of a text box, biological humans looked like the outliers. This capability isn't confined to a university testing lab. The exact architecture used in that study is already deployed across the platforms and apps you use every single day. Anytime you vent your frustrations to an anonymous account or type a private detail into a chat box, you are operating entirely on trust. If our own software is demonstrably better at acting human than we are, there is no longer a reliable metric to verify identity through a screen. You cannot look for typos or emotional nuance when the machine knows how to simulate those variables perfectly. So, returning to that opening question, could you prove your last digital conversation was with a person? The peer-reviewed data states clearly that you cannot. For decades, the Turing threshold served as a strict dividing line between biological reasoning and synthetic imitation. Today, that line no longer exists. Now that text-based conversation is no longer a definitive proof of human presence, we have to ask, what other boundary is next to fall?